first section of Chapter 3 is Parallel Lines and Transversals Part 1. We'll be spending 2 days on this lesson. The learning target is I can identify the relationships between two lines and two planes and name angle pairs formed by a parallel line and a transversal. First vocabulary word is parallel lines. They are coplanar lines that do not intersect. Okay. So the way you denote that is these two parallel lines, JK and LM. Notice line JK, line LM are parallel. This symbol here is the shortcut or how you denote parallel. Skew lines are lines that do not intersect and are not coplanar. So they do not intersect and are not coplanar. These are skew lines, L and M, because they will not intersect and they're not on the same plane. Parallel planes are planes that do not intersect. So an example would be plane A and plane B. A real life example would be the floor and the ceiling. Those are parallel planes. So an example, a couple examples, name all segments parallel to BC. So find BC on your cube. We need to name segments parallel to BC. So notice that BC is vertical. Another vertical line or segment is DA. Another is EH, which is also vertical. And the last one would be FG. Now we need to name a segment skew to EH. I'm going to highlight EH, which is a vertical line. So skew means they're not parallel and they do not intersect. So BC, FG, and DA cannot be skew. DE, EF could not be skew because they'll intersect. So an example of a skew line would be AB. Notice they are not parallel and they do not intersect. Now let's name a plane parallel to plane ABG. Let's first find where that is. ABG, they're talking about this bottom surface here. So to name a plane parallel would be the top. So to name that, don't forget to write the word plane, and I only need 3 letters. So I'll do EFC. Next, we're going to talk about different types of angles. So here we have 2 lines and 1 line intersecting. This line intersecting those 2 lines, the green, is called a transversal. So 2 lines cut by a transversal have special names for all the angles it creates. The interior is between the 2 lines, and the exterior is outside those 2 lines. So you'll see these names, interior versus exterior, and these 5 names, notice have the word interior, exterior in them. Consecutive interior angles, or same side interior angles, are angles that are in the interior of the 2 lines in this yellow and are on the same side of the transversal. 4 and 5 are same side interior, and so are 3 and 6. Alternate interior angles are on alternating sides in the inside between the two lines. 4 and 6 are on different sides of this transversal, but they're in between the two lines. Alternate exterior angles are on the exterior of the two red lines, but on different sides of the transversal. So 1 and 7 are alternate exterior angles, and so are 2 and 8. Consecutive or same side exterior angles would be 1 and 8. They're on the same side of the transversal, but on the outside of those two lines, the exterior of the two lines. The last type are called corresponding. Corresponding angles are in corresponding areas of the two lines with the transversal. So corresponding angles would be 1 and 5, 2 and 6, 4 and 8, 3 and 7. So to name with a different figure, here we have our two lines cut by a transversal. So I will do one example of each. So remember, we also have the interior and the exterior. So interior is in between the two lines, exterior is on the outside of the two lines. So alternate interior angles, I need to look at the interior of these two lines and on different sides of the green transversal. So the two angles that match that would be, for example, angle 1 and angle 2. Same side interior angles are on the same side of the transversal. So an example would be angle 1 and angle 4. Corresponding angles are in corresponding positions. They're on the same side of the transversal, but one is on the interior and one is on the exterior. So an example would be angle 4 and angle 5. Alternate exterior angles are on the exterior of the red line. So alternate exterior angles would be an example of angle 5 and angle 8. Same side exterior angles are on the same side of the transversal and also on the exterior of the two lines. So an example of that would be angle 6 and angle 8. Now, if these two lines are parallel, we can prove some theorems about those angles. So here, in all these examples, these are your two lines. And if these two lines are parallel, you can make assumptions about the angles. So here's your transversals. Okay. Corresponding angles are congruent. So if line L and M are parallel, then corresponding angles are congruent. Alternate interior angles, if these lines are parallel, then alternate interior angles are congruent. If two angles are on the same side interior angles, if these two lines are parallel, then these two angles are supplementary. They sum to 180 degrees. Alternate exterior angles are congruent, and same side exterior angles are supplementary. I go back to the screen, which is not on your notes. You can maybe see why corresponding angles are congruent. So if I look at 1 and 5, if I were to scoot up my line and my angle, what happens is that they lie right on top of each other. Same side interior angles are supplementary, because if I were to scoop my line up, what happens is angle 5 lands right here, which creates a linear pair. That's why they're supplementary. So if I were to do some examples, say we're given M and N are parallel, and we need to find the missing angle measurement and justify. So we're given in all these examples that the measure of angle 1 is 120 degrees. We need to find the measure of angle 5 in this example. So first, you need to decide what kind of angle relationship angle 1 and angle 5 have. Okay. So here are two lines. Here is our transversal. I noticed that 1 and 5 are in corresponding positions. So angle 1 and angle 5 should be the same measure because they are corresponding angles. So the measure of angle 5 is 120 degrees because since M and N are parallel, so this is how you denote it, then corresponding, you can abbreviate, corresponding angles are congruent. Next, I need to find the measure of angle 7. Okay? So I need to see how 7 and 1 relate to each other. Notice they are both on the same side of the transversal, and they're both on the exterior. So angle 1 and 7 are same side exterior angles. So if I were to write that, I know they're same side exterior angles. And what I know about same side exterior angles is that they are supplementary. So to figure out the measure of angle 7, what I do is I take 180 minus 120 to get 60 degrees for the measure of angle 7. Same deal for measure of angle 8. Measure of angle 8 and 1 are on different sides of the transversal, so alternating sides, and they're both on the exterior. So I know that these two angles are alternate exterior angles, and what I know about alternate exterior angles is that they are congruent. So the measure of angle 8 is also 120 degrees. Now you can apply that with some algebra problems. So you're looking at the shape. Okay. What helps is these little arrows denote parallel. What I do for those is I always extend those lines. Okay. Now there's two sets that I need to solve for x and for y. So there's two problems I need to solve. So let's solve for x first, only because they asked for it first. So x is with this transversal. So what I'm going to try to do is figure out what is the relationship between 2x and the other angle touching my transversal and other parallel line. Notice that 2x and that box, also known as 90 degrees, are on the interior of my red lines and on the same side of my transversal. So these are same side interior angles, which means they're supplementary. So I'm going to take 2x plus 90 and set them equal to 180 degrees. To solve, I'm going to subtract 90 and left with 2x equaling 90. Divide by 2 to get x alone, and my x is 45. Now for y, I'm going to figure out what relationship it has using this transversal. Well, this looks like the same problem. I have two angles, both on the interior of the red lines and on the same side of the transversal. So my setup is going to be very similar. I'm going to take y plus y minus 50 and set it equal to 180 degrees. I'm going to combine like terms add 50 to both sides. And divide. So my y is 115. Finally, I'm going to use the same thing here. I see those arrows, which means that these lines are parallel. So I'm going to extend those lines. Next, I need to identify my transversal. Since all my algebra is right by this line here, I'm assuming this will be my transversal. Next, I need to decide how these angles relate to each other. So we're talking about this angle here and this angle here. Those two angles are in corresponding positions, which means they're corresponding angles, which means they are congruent. So I'm going to set x plus 40 equal to 3x minus 10, and so I'm going to subtract x, left with 40 equaling 2x minus 10. We're going to add 10 to both sides. I have 50 equaling 2x, divide by 2, and finally, my answer is 25. And that is the first lesson of chapter 3.